Hello everybody, welcome to your first chemistry flip video. As we go through this, especially in the first few videos that you've had in other classes, be sure to pause the things we go too fast on and rewind on things you didn't quite understand what I say. You're going to need to be paying attention not only to the words on the screen, but also to the words that come out of our mouth. So don't just pause it and write through whatever's on the board. A lot of the information we give, more importantly, comes through the audio of the video, not just the words written on the board. But this first video goes over two things you've seen a lot of in other science classes: scientific method and hypothesis validity. So let's go ahead and get started. So the scientific method, first thing we need to know is what exactly the scientific method is. Now I know this is a lot of writing. Please feel free to abbreviate this in any way that you want, as long as it's correct and accurate. You can check that with us in class the next day. But they're basically a set of rules and procedures that we use to solve a problem or to observe something that has happened in the world, in nature. They basically make a way to test ideas, and those ideas need to be proven right or wrong. This is the way that science happens. Now this all starts with something called the hypothesis. You've all heard the hypotheses before, explained a whole bunch of different ways. In biology, they may have taught it to you as an educated guess. That's close. Now we're going to take it one step further. It's a possible explanation for the observations, so they're right in saying it does not have to be correct. It just has to be a possible statement. But there is a correct way to do hypotheses and an incorrect way to do hypotheses. And you're going to have to be able to decipher if one hypothesis is correct over another. So this has two criteria. Here they are. It must use conditional language. That's easy. It's going to have might or may statements, something that doesn't take a direct approach to a statement. It's never going to say this is the way that it is. It's just going to say very conditional language. You'll figure out how to do that. And what may be difficult to you guys is figuring out if it's testable or not. But you'll get the hang of it because we're going to do a lot of practice in class. So here it is in a little visual form. Not really anything to write here, but we always start with a question. We observe that question in nature and we form that hypothesis. From that hypothesis, we test the hypothesis by doing an experiment. We collect our data in our experiment, and then we analyze that data. If it's supported, we go on and we talk about a results page. If it's not, we go back and try to figure out why the observation is going the way we observed it to be. That's really all it is. So you have the strange case of beriberi there in your notes. I'm not going to read it to you. Please pause and read that, and we're going to go over these questions together. All right, I hope you've read it by now. What was the original hypothesis? That beriberi is caused by a bacteria. It's not a good hypothesis. That's the last part up. We're going to start right back here. All right, so I hope you read it. Let's look through it. What was the original hypothesis? Remember, it has to be conditional and it has to be testable. So if you read through it, put the third line down, you see the conditional statement there. Those might and may words will stick out to you the more you do this. But it says the disease might be caused by a bacteria. So there is your hypothesis. I didn't think they'd all come up at once. Awesome. Anyways, how was the hypothesis tested? You can read the very next sentence. They injected the blood of sick people into chickens to see if the chickens became sick. They did. Should the hypothesis be supported or rejected? Obviously, it should be rejected. The control group should always be control. If something happens to the control group and the test group, something there is going on that we're not seeing. So it should be rejected because our control group became sick. We'll talk more about that control group is in another video. So what's our new hypothesis? The lack of thiamine in polished rice may be causing people to contract beriberi. So if you got questions, please write them to the side. And next time you come to class, we'll talk about your questions. Alright, so now you've got 3 ways to practice. I want you to read through those short phrases, pause it, make a statement whether these are valid hypotheses or not, If they're not valid, tell me why. So go ahead and pause and try those. All right, so welcome back. Hope you read through those. So Dr. Leggett with Tigger and Nala, is that a valid hypothesis, yes or no? The answer is no. The reason why it is no, again, I think I'll come up, is because enjoys is not a unit of measurement. Enjoy is an opinion. I might say I enjoy something more than you do. There's no real way to test that. So this is not a testable hypothesis. It is also not conditional. Number 2, Mr. Coder. It is a valid because it is a valid hypothesis because it is testable and conditional. Number 3, the leaf color is not valid because it's not conditional, because you see there, if the leaf color change is related to temperature. Is not conditional. Is what it is. That's it. That's all for this video. Video 2 will cover qualitative versus quantitative data. Got questions? Write them down in the borders and come see me in class tomorrow.